256 fire hotspots are burning across Indonesia right now, today, May 6, 2026, detected by NASA satellites before the dry season has even started, and scientists are using a word they almost never use this early in the calendar year. They are using the word catastrophic, not as a prediction, as a description of what the data already shows. 256 points of heat signature glowing on a satellite map of an archipelago of 275 million people. An archipelago sitting on top of the single largest tropical peat deposit on the surface of this earth. And if you think this story is about wildfires, you have not yet understood what is actually burning. But that is not even the real story. The real story is what is underneath the smoke. Beneath those 256 hotspots detected today by NASA's Terra and Aqua Modus satellite system, beneath the orange glow on the thermal maps coming out of Indonesia's Lepan monitoring network and the BMKG meteorological agency in Jakarta, beneath what looks from space like a scattered collection of ordinary vegetation fires, there is a geological time bomb that has been building for 15,000 years. Indonesia sits on top of 22.5 million hectares of tropical peatland. 22.5 million hectares, and that is an area larger than the entire United Kingdom. And this peat, this dark, dense, carbon-saturated material that forms millimeter by agonizing millimeter over millennia, this ancient underground accumulation of decayed and compressed organic life, stores 57 billion tons of carbon. 57 billion, not million, billion. That is more carbon than the entire atmosphere of Earth absorbed in 3 years of global industrial activity combined. It is stored underground in layers that in some locations reach 18 meters deep. 18 meters, that is 6 stories of a building, straight down into the earth, made entirely of compressed biological material that has been accumulating since the last ice age, and right now, parts of it are on fire. The monitoring network that tracks these hotspots is one of the most sophisticated early warning systems on the planet. Lepan, Indonesia's National Institute of Aeronautics and Space, feeds real-time satellite data to the Ministry of Environment and Forestry. The BMKG, Indonesia's meteorological, climatological, and geophysical agency, issues fire weather alerts tied to atmospheric moisture readings across 34 provinces. NASA's FIRM system, the Fire Information for Resource Management System, provides global thermal anomaly detection updated every few hours. All of these systems are watching. All of them are registering what the data shows, and what the data shows on May 6, 2026 is this. Indonesia is entering its 2026 fire season with burned area already at 32,637 hectares by February alone, 20 times higher than the same period in 2025. By April 14th, satellites had registered 735 high-confidence hotspots nationwide, nearly 3 times the count from the same date last year. And since January 2026, the independent watchdog Pantau Gambit has recorded 23,546 hotspots in peatland areas, specifically peatland, not ordinary forest. The distinction matters enormously, and here is why. When an ordinary forest burns, it burns what is above ground. The trees, the canopy, the undergrowth. The fire moves across the surface, and when the fuel is exhausted, it stops. You can see it from the air, you can track its perimeter, you can draw a line around it. But when peatland burns, the fire goes underground. The smoldering front moves downward into the peat layer at a rate that is invisible from the surface, burning material that has been below ground since before the first human civilization built a city. Peat fires do not behave like surface fires. They do not respond to rain the same way. A heavy rainfall can suppress a forest fire in hours. A peat fire can continue burning for weeks or months underneath standing water. The ground above it may look wet, it may look calm. But 3 meters below the surface, the ancient carbon is combusting in slow, oxygen-starved thermal decay, and it will not stop until the fuel is exhausted or the water table is fully restored. This is not a theory, this is documented geology. Researchers measuring carbon monoxide levels at Palangkaraya Airport in central Kalimantan during peak burning years recorded CO concentrations 30 times higher than normal. Not near the fire front, but at an airport, in a city, as the invisible gas seeped up from underground combustion happening kilometers away. The numbers around the March 2026 hotspot count should stop every person reading this cold. In February 2026, Pantau Gambut recorded 5,114 peat hotspots. In March 2026, that number became 12,942, nearly tripling in a single month. And this is March. This is the end of the wet season, the period when fire activity in Indonesia is supposed to be at its annual minimum, when the monsoon rains are supposed to be suppressing the risk. The fact that fires are escalating in March 2026 tells climate scientists something deeply unsettling about the condition of the peatland itself. Because here is what the data actually shows. The peat is no longer waiting for the dry season to burn. The hydrology is so degraded, the drainage canals cut by palm oil and pulp and paper companies so extensive, that the peat is drying from within regardless of what is happening in the sky above it. The wet season is no longer sufficient protection. The system is not dormant, it is awake. And now consider what is coming. Indonesia's BMKG places a 50 to 80% probability on a weak to moderate El Niño developing in the second half of 2026. But the U.S. National Oceanic and Atmospheric Administration, NOAA, is not being as gentle in its projections. NOAA forecasts show a 50% chance of a strong El Niño and a 25% chance of a very strong one, based on projected sea surface temperature anomalies of at least 1.5 degrees Celsius above average in the central and eastern Pacific. Scientists studying Indonesian fire patterns published research in the journal PLOS-1, showing that the most severe fire years in Indonesia consistently coincide with two simultaneous climate anomalies, a strong El Niño and a positive Indian Ocean dipole. The Indian Ocean dipole is a seesaw of ocean temperature between the western and eastern Indian Ocean. When it goes positive, the waters north of Australia and south of Indonesia cool, the moisture they would normally supply to Indonesia's atmosphere is withdrawn, and the islands bake. In 2026, both of these anomalies are beginning to emerge at the same time. The researchers who wrote that PLOS-1 paper are describing conditions that are beginning to mirror the years that Indonesia still has not fully recovered from. And here is where this story becomes genuinely alarming. Because we have seen this before. We have seen exactly this before. In 1997, Indonesia experienced an El Niño year so severe that the fires burned an estimated 9.7 million hectares of forest and peatland. 9.7 million hectares. The smoke generated by those fires blanketed Southeast Asia for months. Satellite imagery from that year shows the entire island of Borneo, the entire island of Sumatra obscured by a continuous brown haze. The official death toll from the 1997 event was 527 people, but that number, as researchers have noted with increasing candor, is almost certainly a profound underestimate because it only counted direct fire fatalities. The epidemiological death toll, the people who died of respiratory failure, cardiac events triggered by PM2.5 inhalation, infants who could not draw a breath, was never systematically counted. Scientists who have since modeled the 1997 event believe the actual death toll may have exceeded 100,000 people. The evidence is still there. It is in the hospital records. It is in the mortality statistics for that year across Indonesia, Malaysia, and Singapore. It is in the lung tissue of a generation of children who grew up breathing air that the World Health Organization would classify as hazardous for years afterward. Then 2015 came. And 2015 was worse. The 1997 fires were the event that forced the world to pay attention to Indonesian peatlands for the first time. The 2015 fires were the event that forced the world to confront what happens when the same system ignites under the same conditions 18 years later, after 18 more years of drainage, deforestation, and peat degradation. In 2015, between June and October, Indonesia burned through 2.6 million hectares of land, much of it peatland. The fires produced 1,043 million tons of carbon dioxide. In a single season, from a single country, the CO2 output exceeded the average daily greenhouse gas emissions of the entire United States economy for the duration of the event. During the peak months of September and October 2015, Indonesia's fire emissions exceeded the total CO2 output of the entire European Union for the same period. Researchers from Harvard University and Columbia University published a study estimating that the 2015 fire and haze event caused upwards of 100,000 premature deaths across Indonesia, Malaysia, and Singapore. Indonesia alone suffered 91,600 of those deaths. Malaysia lost approximately 6,500 citizens. Singapore lost 2,200. The Indonesian government's official count was 24 deaths, 24. The gap between the official count and the epidemiological estimate is not a rounding error. It is the difference between a manageable statistic and a humanitarian catastrophe that was happening invisibly, in hospitals, in homes, in the lungs of people who never made the news. 500,000 people sought medical attention during the 2015 haze crisis. 500,000. The smoke they were breathing was not ordinary smoke. Peat fire emissions contain formaldehyde, acrolein, benzene, carbon monoxide, cyanide, ammonia, and nitrogen dioxide in concentrations that regularly exceeded WHO safe exposure limits. These are not trace contaminants. Formaldehyde is a known carcinogen. Benzene affects the blood, the brain, and the immune system. Acrolein causes immediate cellular damage to airway tissue, and the particles were not ordinary particles. The PM2.5 fine particulate matter generated by peat combustion is small enough, smaller than 2.5 microns, smaller than a red blood cell, to bypass the respiratory system entirely and enter the bloodstream directly. In Palangkaraya, a city of 260,000 people in central Kalimantan, a senior midwife named Bidan Erna recorded what she witnessed in October 2015. 5 women came to her clinic in a single morning seeking care for prenatal deaths, 5 in one morning. She said she believed the deaths were caused by the lack of oxygen and the concentration of toxins in the air the women had been breathing for weeks. In 2015, the Indonesian agency BMKG called the crisis a crime against humanity. That phrase came from a meteorological agency, not a human rights organization, a meteorological agency. Now look at the city of Pontianak. Pontianak sits almost exactly on the equator in West Kalimantan, on the island of Borneo. Its population is approximately 650,000 people. In January 2026, parts of West Kalimantan experienced up to 11 consecutive days without rain, even as other areas of the island were flooding. In the same period, 2,216 peat hotspots were recorded in West Kalimantan province alone. The air over Pontianak thickened. Hospitals recorded increases in respiratory presentations. Children wore masks to school. The smoke that settles over Pontianak does not come from fires in the jungle far away that have nothing to do with the city's residents. It comes from peatland that surrounds the city, peatland that was drained to grow oil palm, peatland that sits a meter or less below the surface in many areas, peatland that is now burning underground beneath farms, beneath roads, beneath the communities that replace the forest. The people of Pontianak are not watching a distant natural disaster. They are sitting inside it, breathing it. And consider the city of Palembang in South Sumatra, 1.5 million people. A major river city, a trading hub, a place where families have lived for generations beside the Musi River. South Sumatra was identified in the Harvard and Columbia study as the province responsible for nearly half of all smoke exposure during the 2015 event, nearly half. The fires in South Sumatra's peatlands and timber concessions sent toxic PM 2.5 across the entire region. In 2025, fire hotspot activity in Indonesia sent smoke plumes visible by satellite drifting across the Malacca Strait into peninsular Malaysia. The question the people of Palembang would ask, if they saw what the satellite data shows for 2026, is the same question they have been asking for 3 decades. The question is not whether the smoke will come. The question is whether anyone will stop it before it does. Here is what connects these fires to something larger than Indonesia's internal land management crisis, because this is not an isolated event. The Indonesian fire system is embedded within 2 global systems that are right now operating in ways that amplify each other. The first is the Pacific Ocean climate engine. El Niño events are driven by the warming of equatorial Pacific surface water and the suppression of the normal upwelling of cold, deep ocean water along the coast of South America. When El Niño is active, the Walker circulation, the vast atmospheric conveyor belt that distributes moisture across the tropics, weakens and reverses. The moisture that normally flows westward over the Pacific and rains over Southeast Asia instead stays locked in the central Pacific. Indonesia dries, the peat dries with it. And what the data from NOAA in 2026 is showing is a Pacific Ocean that is beginning to warm in precisely the pattern that precedes a strong El Niño event. The probability numbers are not certainties, but probability numbers are what the science works with. And a 50% chance of strong El Niño in a country where strong El Niño means 2.5 million hectares of peatland on fire is not a number that anyone should be reading calmly. The second global system is the Indian Ocean dipole, and this one is less discussed but equally consequential for Indonesia. The IOD, as scientists call it, is the Indian Ocean's equivalent of El Niño, a seesaw of temperature anomalies between the western and eastern parts of the ocean. When the IOD is positive, the eastern Indian Ocean cools. Since Indonesia sits at the eastern end of the Indian Ocean, a positive IOD removes moisture from the atmosphere directly above the country's most fire-prone islands. Research published in PLOS One in 2026 confirmed that the co-occurrence of El Niño and a positive IOD is the single most reliable predictor of catastrophic fire years in Indonesia. In 2015, both were strongly positive simultaneously. In 1997, both were strongly positive simultaneously. In 2026, the IOD is beginning to trend in a direction that concerns researchers. The monitoring is in place, and detection is possible, but prediction is not. And that careful language carries its own warning. And then there is the peat itself, not the fires above it, not the weather systems driving the drought, the peat itself. Indonesia holds 57 billion tons of carbon in its peatlands. To understand what that number means, consider this. The entire global atmosphere currently contains approximately 870 billion tons of carbon. Indonesia's peat represents roughly 6.5% of all the carbon currently in the atmosphere sitting underground in a tropical archipelago that is on fire before its dry season has started. In some locations in central Kalimantan, peat layers reach 18 meters in depth. That is not a layer of soil. That is a geological formation, a carbon archive built over 15,000 years since the last ice age, since sea levels began to rise after the glaciers retreated and the swamps of Borneo and Sumatra began their slow accumulation. Every millimeter of that peat took between 1 and 5 years to form. The 10-meter deep peat deposits under parts of central Kalimantan represent between 10,000 and 50,000 years of biological accumulation. When it burns, it does not reform on any human timescale. When it burns, The carbon that took 10,000 years to store returns to the atmosphere in a season. By March 2026, the burned area in Indonesia had already reached 32,637 hectares, about 3 times the land area of Paris. This number is not the area of active fire. This is the area already turned to ash and scorched earth before the dry season began. Before Kalimantan's peak, fire months of August and September. Before the El Niño that is building in the Pacific has fully expressed itself. Before the positive Indian Ocean dipole that researchers are tracking has reached its strongest phase. The number on May 6, 2026 is not the worst number. It is the earliest number. And what the trajectory of that number shows, from 29 hotspots in January 2025 to 110 in January 2026, from 5,114 peat hotspots in February 2026 to 12,942 in March 2026, from burned area 20 times higher than the previous year at the same calendar point, is not random variation. It is escalation. And the question is not whether it will continue to escalate. The question is how far it will go before the conditions that drive it reach their peak. The agency tasked with peat protection in Indonesia, the Peatland and Mangrove Restoration Agency, has been fighting a difficult battle. Researchers at Pantau Gambut in 2026 found that 1,824 of the January hotspots they recorded, nearly a third of the total, were inside the concessions of commercial companies. 1,700 of those were inside oil palm concessions. This is not accidental burning. This is structural burning. It is burning that occurs because drained and degraded peat ignites under conditions that intact waterlogged peat would not. Decades of canal construction to drain peatland for agriculture have lowered the water table across millions of hectares. Once the water table drops, the peat begins to oxidize. Once it oxidizes, it shrinks. As it shrinks, it becomes more porous. As it becomes more porous, it dries faster. And once it is dry enough, a single electrical storm, a single discarded cigarette, a single agricultural burn that escapes its intended boundary turns it into an underground furnace that no surface suppression can easily stop. The monitoring systems that exist to detect all of this are sophisticated. NASA Firms provides near real-time satellite thermal anomaly data. LAPAN provides Indonesia-specific hotspot mapping. BMKG provides fire weather forecasting tied to atmospheric moisture and drought indices. The Sapangi system run by the Ministry of Environment and Forestry aggregates all of this into a public-facing dashboard. Every one of these systems is showing the same escalating trend, and none of them, for all their sophistication, can fully prevent what happens when the conditions are met. They can detect, they can warn, they can quantify the damage after it occurs. What they cannot do is stop the Pacific from warming. What they cannot do is stop the Indian Ocean dipole from trending positive. What they cannot do is rewater 6 million hectares of degraded peatland before August. The monitoring is extraordinary, the science is extraordinary, and the question of whether it is enough has not been answered by any instrument on Earth. The people who will bear the first and heaviest cost of what is building are not the scientists publishing the warnings. They are not the policymakers issuing the statements. They are the 650,000 people in Pontianak who will feel the air quality degrade around them before the official alerts are issued. They are the farmers and fishing families in the riverine villages of central Kalimantan whose livelihood runs on the water systems that cross-cut the peat domes, who have watched the canals dry earlier each year, who have watched the haze return each dry season, who have buried neighbors from respiratory illness, and have never seen a company held legally accountable for the fires on its concessions. They are the infants in Palembang, the schoolchildren in South Sumatra, the elderly in West Kalimantan, whose compromised lungs cannot withstand another PM 2.5 event at the scale of 2015. These are not statistics. They are 275 million people living on top of the most carbon-dense ecosystem on the surface of this earth while it burns. 256 hotspots on May 6, 2026, before the dry season. 23,546 peat hotspots since January. 32,000 hectares burned by February. A 50% chance of a strong El Niño. A positive Indian Ocean dipole beginning to develop. A peat system holding 57 billion tons of carbon, degraded across millions of hectares, drying from underground. All of this is already happening. The data is real. The measurements are real. The historical evidence from 1997 and 2015 is real. The scientific projections are not speculation. They are probability, and the probabilities are not small. What the science cannot tell you, what no instrument built or planned can tell you, is exactly when the convergence of these systems will produce the event that exceeds the monitoring capacity, exceeds the suppression capacity, exceeds the health system capacity of the countries in the path of the smoke. The science can measure what is happening. It can track the escalation. It can look back at the geological record and say with certainty, this system has catastrophically ignited before, and the conditions that caused it are assembling again. But the precise moment, the precise scale, the precise answer to the question of whether 2026 will merely be serious or will become something the BMKG reaches for words like crime against humanity to describe? That question sits in the Pacific Ocean, and in the Indian Ocean, and in the degraded water table of 22 million hectares of ancient carbon, and in the decisions being made right now in the offices of companies whose concessions are already on fire. 256 hotspots today. The dry season begins in June, the peak is in August and September, and somewhere underneath the soil of Kalimantan and Sumatra, in the compressed darkness of 15,000-year-old carbon, the slow smoldering has already started,